Hey everyone, welcome to our fourth episode of the Golden Path to Spring One. It's basically our pathway to Spring One, which will be happening in Las Vegas in August. At the end, there will be a little bumper thing that tells you a little bit more information on that. Today we have Gerard Klijs, and I can't say that right because I'm not Dutch, I'm sorry,
It's
coming
good
from
enough.
Axion IQ today. So yeah, want to tell us like a little bit about you, what you do and whatnot?
I moved to working for Maxonic about a year ago. Before that, I worked in multiple event-driven architectures, mostly as consultancy, so mostly 1 year at the company, then another. Several things with Kafka related, and with Axonic we have our own event-driven things with also an Axonic server, and that will also be mentioned in the talk a bit. So.
Well, I just added to the things that I said incorrectly, so I'm on a roll today.
So it's Java based, so it works really
Okay.
nice with Spring Boot 3. So we just think a few weeks ago we released the 4.7 version, and that's finally Spring Boot 3 compatible. So yeah.
Yay! Yeah, I was very happy when Spring Boot 3 came around because it made it so that I could just do like Kubernetes using a Kubernetes Java client and have it where I could just build my GraalVM Spring native images by default and not needing Josh's extra like hints package, which is
Yeah.
useful, but it's nice when it's built in. But yeah, so I haven't actually seen any talks before on concurrency control, so I'm super excited to see this. But yeah, I'll let you kick it off. And for anyone in the chat, please ask questions. Depending on timing, some will maybe be answered at the time. Otherwise, they'll be answered at the very end. So
Yeah, I try to keep an eye out, but there's enough time in the end. So yeah.
awesome.
Can you move to the slides? Yes, thanks. So I'm going to tell something about concurrency control and event-driven architectures. So let's go to what I'm going about to say. So first I want to explain, well, what is an event-driven architecture, or at least what do I see as an event-driven architecture? And then a bit of what events are, because yeah, they are messages, but what kind of messages, what typically is common of every event in an event-driven architecture. What is concurrency control? Then a bit about two different ways to enable concurrency control. Then if I have time, a demo, but I might not have time. So then if there are related questions, I might pull out a demo. It's also on GitHub, so there's a link there you can show. And then what's there to learn? So let's go to it. What is an event-driven architecture? So an event-driven architecture is pretty centric around messages. So that makes some things easier. So for example, you have an UI, you have an application, and then from the application, you send them either to an event bus or an event store. Yeah, for my talk, they are kind of interrelatable, but of course, with an event store, that you probably persist forever. And with an event bus, it might just live there a short time. But what's important to get really most out your event-driven architecture is that at least multiple applications can easily get the same event. So not like the standard message queue, and once one application has taken the message, then it's gone. So you really want to make it easy for different applications to also see those messages. So then if you have one application and you put your messages just to that event bus, then a second application can easily consume them and maybe also put something on the event bus. And then you can easily explain it. So for example, if you have something to place orders in application 1, and then you register them in the event bus, and you have something like, and you later on, and you have a warehouse. So the warehouse is in application 2, so it wants to know what's ordered to send it out. And then later on, for example, you could build another application to send notifications. So they can combine both the events from application 1 and 2 to send email notifications, for example. And then you can easily scale it up independently. So some of the benefits of an event-driven architecture. you have decoupling. So the several services, they don't really have to know where they are or how many instances there are, because they are all communicating through this common thing. You can also easily scale them up. So if one app can only, for example, handle 1,000 messages a second, then you can easily just add a second application, so they both then have 500 messages a second, and all goes well, since you can easily split those up. Resiliency, so if one application goes away, it's not ending. So say if you have 3 or 4 applications and one of them dies, then the other one can still handle all those messages and make sure nothing really breaks. And some other benefit, if you do all your traffic with messages and you persist it forever, then you can have a history. So that's mostly interesting if you have something like a bank or something and you really want to go back in time. There's also some challenges with event-driven architectures. One of the most common is who maintains the middleware. So I've been in my past at several projects where Kafka was used because, oh, that's easy, and then we can just put messages on Kafka. Some other application just gets it from Kafka. But yeah, who maintains the Kafka? So if it goes down, who's responsible? Who makes sure it's performant? That sometimes can be a challenge. Of course, you can also take it as a service. But then, yeah, who's paying for that? And then even if you have a cloud service for Kafka, you still have things like access control and things like that you need to be aware of. Also, which format do you want to use? So there's always some rules about it. Also, how to test individual servers can be difficult, because what you can is, or most cases, what you can do is if you know what kind of messages you get in and what kind of message you need to send out for each individual service, you can just create those messages, see if you get the right messages back. But it can be more challenging than if you have just a simple CRUD app with a database. So then, what are events? So all the applications need to be able to handle events. So mostly there's something like a versioning system. And this example is of a cloud event. So they have a clear spec version that needs to be there, and that's now at 1.0. But then it could change, and then you might need to handle other parts of the message differently. And there's also some parts of the events that are obligatory and sometimes that are not. It's always easy to have something of a type, so then you immediately know if this event is interesting for you or not, and also how you can maybe deserialize it if that's needed. It's also nice to have a source of the event. So this is, for example, pointing to a GitHub repository. You can also use it differently, but then you might know where can I find more information about this event, or where does it originate from. It's also nice, especially for the deduplication, if all events have a unique ID. So then you know for sure, even if all the rest of the information of the event is the same, that it are really two separate events. And not just the same message twice. It's also very nice to have a timestamp of events, because that's also something typical of events. It's something that happened at a certain time. It won't change again, because it's in the past. But it's nice to know when it happened. And then the base of the message, that could be a data content type. In this case, it's application JSON, and then some simple data in the JSON format. So there are several ways how events can be created in such architecture. For example, it could be a mapped external event. So this could be an API from an external party, and it just calls on you, and then you know, oh, something happens via that API, and then I'm creating an event for my applications inside. It could also be an internal event, so someone that pushes a button in an internal application or something. It could also be based on the time and the state of the application. So for example, in Axon, we have a concept called sagas, which is to coordinate between aggregates. That gets a bit complicated, but at least sometimes you want to have something like a deadline. So if the transaction didn't go through in 5 seconds or 5 minutes, then revert the transaction. So then based on that time expiring, you have again some kind of event. And the fourth one, and that's the main thing I want to handle in the presentation, is if you have a command like invocation. So that's a command is a specific type of message that says that I want to change something. So in the example I will go into, for example, I want to register a member, or I want to order some stickers. And that's really like a command. And then that might lead to an event like a user is registered or stickers were ordered. So then something about concurrency control. So this is what, in this diagram, this is like the boundary. So that's something that comes in through an API. Then there's 2 command handling applications. There's an event bus or an event store. At this point, that's not really important in an application. And what can happen, so once you scale out, if you don't take this in mind, is that you could have a command that at the same time, for example, for the same account, goes to 2 different handling applications. So for example, if it's a bank and you want to subscribe a certain amount, but you can only subscribe it once, then it does happen twice. And then the third application that's reading all those events, it thinks, well, what has happened here? Because something happened here that isn't supposed to happen. And then it's very hard to recover since you can't change past events. So then you need to go into mitigating events, but then you have some inconsistent states in between. So that's all very hard to solve once you're there. So it's better to prevent it. So to better explain the 2 solutions, I thought of a kind of simple problem, because once you talk about currency and things like that, it gets difficult. So for this example, there are stickers that you can get from a jug. For that, you have to register. And once you have registered, you get 50 credits. And to order the stickers, it's 30 credits. So you can only order the stickers once. And if you would register at the same time and then hit it, it would still you would only get 1 sticker. So the second call does need to fill. So so this is the example. So you do 1 call, the credits get subtracted by 30, you do the second call, and then you return an error. And that's pretty easy once you have just 1 application and just 1 database. But at the point that you get a large system and lots of different instances, this becomes much harder to be 100% sure that it happens. And like I explained, if there is some error, it could be very hard to recover for it. So one of the ways to solve this is by using a database and making sure that you use either optimistic locking or some other way that you know that there's only 1 application changing an entity at a time, or at least then when a second application also wants to change it, that it fails. So how this kind of works, that most of the time with the version. So in a database, there's some kind of entity. So that could be like a member or something. And once the first invocation takes place and the application changes it, it comes back with version 15. And then and then it updates, the application 1 updates it with version 16. And then the second one wants to update it. also to 16, but it can't since the database, it's already at 16. So then you have an error, and then ideally to recover from that, you would just have the application to get the state again, see if it's still valid, and then update the entity with version 17. But then still you have to and from the database in this case. So it's not ideal, but at least you prevent the errors. Then the other way is a single writer principle. And in that case, you make sure there's some way, so probably by routing the messages, to make sure there's one instance handling both of them. Yeah, I get to the outbox pattern in the example. But that's from a question. And now I'm kind of my track. Yeah, so in this case, you make sure that there's, for that one account or that one member, that there's one application handling them, and that application knows, oh, I'm already busy handling this member or this account. So then once the second comes in, they really become one after the other, and then the other one is failing. So that's another way to solve it. And kind of ideally, you have both ways. So you try to work with the single writer principle, because then you don't have the additional overhead of trying to write to the database, retry again. But then combined with the database, you have the assurance that it's 100% valid. Because if you only rely on the single writer principle, you might, in some exceptional cases, do run into errors, and then it's hard to recover. So now I'm going to the outbox pattern using a database. In this case, it could be PostgreSQL. Using the BCM to create events from the database, and then Kafka to store the events and share them with other applications. So in this case, from the API or whatever it is, you have a command like invocation, then you write a message to Postgres and then return the response. Then if you make sure that there's optimistic concurrency in the database and pick certain tables where you also write those events in the same transaction, then you're sure that once it's valid and it's not reverted, the event came true, then you can use Kafka Connect to pick up those changes. Yes. That Kafka Connect thing is using the BCM, and that's basically reading the log of the database, and then from the logs of the database, it will create events. But those events will always be in JSON, and you probably want them at least schematized, because those are just pretty raw and also contains all kinds of meta information you probably don't want in the events that you want to share with other applications. So then you need some Kafka Streams app to make them schematized and have those in your Kafka cluster to share with other applications. So for this to work, it's important that you have optimistic locking where you need it. So in this case, it tries to check for the new registration if it tries to get a member registration from the database, and then it checks if it can set the credits, then it will persist the new registration with less credits, and at the same time it will also write an event that the events were ordered. So, and since it's transactional and since it's locked, they will always go, or everything will go correctly. And then the event is created, or somehow it will fail because at the same time another one was also updating it, and then it fails, and then the event isn't created. Then for the second solution, and that's also the one I have in the demo, but I'm not sure It seems to be blurry, but that's out of my hands. Could be your connection. Yeah, so for the second solution, I will be using Axon Framework and Axon Server. That might not be very familiar to most people, unlike Kafka. So Axon Framework is around for quite some time now. It's centered around DDD CQRS, and it's Java framework, which, yeah, like I mentioned in the introduction talk, works well with Spring Boot. And recently, we are also Spring Boot 3 compatible. And it works kind of heavily on annotations. So there's some people that don't like that, but yeah, that's the way it currently is. And then it makes some things easier for you. So there's concepts like aggregates, sagas, and it takes some time to learn. But if you are familiar with it, it makes things really simple to set up and have CQRS and event sourcing working, and also solving the concurrency problem. And then Axon Server, that's an infrastructure component that's not been around as long as Axon Framework, but was added later because they noticed that if using a relational database and you have a lot of events, then eventually it becomes slow, which makes kind of sense. For a relational database, all events are equal. And for an event store, the most recent events are treated differently than older events. So you can optimize, and you can also optimize because events in the past are never changed. Well, a relational database, you can change everything. So you can also optimize in that way. Yeah, so this is more or less an overview of what it does. So it's also very suitable for microservices, basically because everything is done with messaging. So not only the events are messages, but also the commands are messages, and also the queries is done in the messaging style. So you could just put a query to the network, to Axon Server. It will route the messages to the correct application that can answer that question for you and then give you the answer back. So you can make those applications really small if it's something that takes use of CPU, and then just scale that small part of your application apart from the rest. Axon Server, some things I missed. Well, the routing is an important one, and the event store. Observability, yeah, so you can also in Axon Server see which applications are connected. And Axon Server, if you have the Enterprise Edition, you can also run in a clustered version. So how does it work with Axon Framework and Axon Server? So then you have a specific message that's a command. That's kind of sent from the boundary that goes into an API app. Then so the first one is just something like an API call, just that could be just an HTTP call. Then the API app makes it into a real an Axon command message that's sent to Axon Server. Then Axon Server will route it to a command handling app, and it does so by using a hash of the aggregate ID. So it knows, for example, if it's for a certain member instance, then it will always route the messages the correct way. So this is kind of like the single writer that will get the messages from Axon Server, and then if it's fine, send a sticker ordered event. But it could also be an error once there are not enough credits anymore. This is kind of how it works with, this is a kind of simplified version with Axon Server, with Axon Framework. So you declare a command handler that's handling the commands that will each time kind of retrieve all the events that were already for that aggregate. And then if there are still enough credits, then it will go through and apply the stickered ordered event. And this is also an aggregate, so this is used to build its state. So once a member is registered, it knows the ID and the credits from the event. And then when stickers are ordered, those are reduced. So this is kind of with Exxon Framework and Exxon Server, it's combining them both, but because it's directed to a specific instance to handle it. So in this case, the two messages are for a different aggregate, so they are routed differently, and that's done using the routing strategy to determine a specific key that's for that specific aggregate. The demo application, I can quickly show something. If you can turn it over to the my laptop screen. Yes. So here I've, from the URL, the thing running. And it's using GraphQL. I can zoom in a bit. Yeah, so for example, now I can create a new member from the registration. Then I need that ID. And then, for example, this will order 1 stickers. So the first one goes fine. And then the second one, I get an error back because I only have 20 credits left. And that's not enough to order the stickers. I won't go into the code now, but that might be if there's any related questions. So now I'm going to the close, so I can go back to the slides. So what is there to learn? How do they compare? I find I've did work also with Kafka, and it's especially nice if you already have kind of a legacy and already working with the database. Then the step into event-driven architectures with the outbox pattern is pretty nice. But I do see that it has a lot of moving parts and a lot of things to keep track of. With Exxon Server, it's a lot easier. Because you only need Exxon Server as the middleware, since it's both routing and the event store. That's mostly makes things easier. What else is there? There's also Akka. I didn't mention it because I don't have enough experience with it. I might add it at some time, but well, not now. And also in the demo application currently, I don't have the setup with Kafka and the Besium. That's also something I might add in the future. Is it needed? That's always a very good question. I think there's already also enough talks about microservices and if you really need them or not. Well, it's always increasing complexity. Let's move towards using messages between things, and you might just get away with a simple monolith, and then you don't need it, but you never know when you need it, and probably, yeah. So it could be nice to think about it when you don't need it yet. Any questions left I can answer? But I think there's not any more. I see my, yeah, so we have a discuss page. That's always nice for if you have questions about Exxon Framework or Exxon Server. My Twitter handle, if it's good, my DMs are open. If Twitter also allows you to send DMs, which sometimes isn't the case, you can reach me there. I think that's about it.
Awesome. Thanks. This is super cool.
Thanks.
Let's see. There we go. Yeah, like it's nice just seeing all the people like posting in the chat. So we know that they're there, but it seems like you did a really good job of explaining things. So, and then this is going to be up on multiple different YouTube channels, or depending on where you're all looking at right now. But it's on VMware, Tanzu, and Spring Developer, and it's also on Twitch. So you can watch this afterward, and people will see it if they missed it live. We're doing this basically every single Tuesday and Thursday between now and the actual conference in August. So yeah, thank you for doing this.
Yeah, so one nice remark about the autoconfig. That's, yeah. One thing that was also added with 4.7 was the auto configuration for Mongo. So you can, for the commands part, we do use and prefer to use Exxon Server, but for the queries part, you're free to choose whatever you want. And for the 4.7, you can easily hook into Mongo. So the demo application actually also uses Mongo. So then from the events, it creates a representation, and then those queries are routed by Exxon Server, and then against the Mongo instance, it will answer the questions.
Awesome. Sweet. Yeah, if anyone has any last-minute questions, you need to throw it in right now. Otherwise, you'll have to ask on Twitter or something else after the fact.
Do you have any questions, Tiffany, or?
I'm still just trying to like understand it all because I didn't know anything about this topic prior to this.
Yeah, that can be
I'm gonna be
intimidating.
watching it again afterward to actually like have it sink in more.
Yeah, that's like why I prefer to have people in front of me, because then I can see, or I can ask who knows about Kafka or not, and then explain things more or skip ahead, but yeah.
Yeah, I've dealt a little bit with like Kafka, dealt a little bit with like RebMQ and such, but like it was for working on a Blogger guide that I did when starting at VMware. There is a question. What is your suggestion for either custom or Axon?
I would say Axon, since at some point you run into problems that will be hard to fix with custom things. Like the bases are simple. For example, if you have an entity and you get into hundreds or of events for that entity, and then with event sourcing, you want to each time get those 100 events, build the aggregates, and execute something. Then you want to use caching, or you want to use snapshot events. And then if you use the framework, that's all built in and easily configurable.
And I also, oh, sorry.
Yeah, I would prefer a solution too, but I'm kind of biased. I've also been in places where solution one took like a long time. So then I know of one place, then we had kind of protobuf definitions for the events. And those were also kind of hard to change, and that had to go through some people. So then it's also very hard to change things. First, you have to get the new proto file, or get a new protocol file. You need to have a topic on Kafka, and then etc. etc. Well, with Exxon, it's very easy. And you could separate them by using several contexts, but you can much easier work together.
Sweet. How long have you been, like, I guess, dealing in this specific space?
I've kind of slowly rolled into it, because in the past I've worked with CMS, but then at some point they were already kind of using Kafka. And I think around 7 years ago, I started working on what's now called Actual. They have their own not their own implementation, but their own things around Kafka, and we put that in place for the Rabobank in the Netherlands. And that was the first time I was fully working with event-driven architecture and really thinking about how do you make it as easy as possible for the teams working with it.
Cool. Well, thank you so much again for doing this. Oh, okay, there's another one. Is it internally using Spring's event bus?
I don't really know for sure, to be honest. I don't think so, but I'm not, because I'm not working on the Exxon server team. So at some parts of the Exxon server are kind of black boxes to me. So I don't know everything.
It'd be impressive if you knew everything about all the different things. There's just so
Yeah,
much stuff, and it just keeps
exactly.
expanding, growing, and changing over time.
Yeah, it's already hard to keep up my Kafka knowledge to date. So
That's how I feel about Kubernetes. I feel like I'm always running behind.
and then Java is also
Oh,
moving
yeah.
with Loom and things. Yeah.
Yep. I need like a bigger brain and better memory to just like pull and time. I need more time. Awesome. Cool. Well, thanks everyone for joining. Come join us next week. And also please come over for the conference. So we have it's VMware Explorer and Spring One all smushed together between August 21st and 24th in Las Vegas. So please come and join us. And thanks again for watching. And thanks, Gerard, for doing the stream today.